Hiya guys, and welcome back to Aid's Workshop. So where are we? We're between Christmas and New Year. I think we're 29th today. I did have to go into work yesterday, but that's a whole other story. This is the first time since the last video I put up I've had a chance to get in the shed. So again, I'm working on two projects at once here. The mini lathe, trying to get the wiring wrapped up on that, and trying to make a few steps further forward with the Webster engine. Now, in the previous video, I think I showed the 4mm belts, and since then, let me open the packet. At least I hope that's what's in the packet, but I'm pretty sure it is. Yeah, since then the correct belts came in. I did manage to order the belts in exactly the same length, so I've got two of those. So yeah, 6mm wide. So I've got the correct belts for that now, so it means I can get on with making the camshaft, or making the camshaft, making the bearing holders, the carrier. We did show the little carrier being made in the last one. I haven't gone any further with that yet, but the bits I've got together to be able to make a few steps further forward with that. So we'll start off with the mini lathe, a bit more on the wiring, and then we'll move across then onto the Webster engine camshaft, shall we call it. So start fitting some of the sockets in the box. I just want to get as much done on the box internally before I fit it. So oh, you can't see there, hold on, that's okay, just put a 6mm pilot in there. I got my step drill here. First socket has a 20mm rebate in it. I've marked a black line on the drill. I think that drill's a little blunt. I nearly dropped the box as well. Seems to be burning up. I'm going a bit fast. Just slow it down. That's it. Okay, a little bit of a deburr using the next step. So the socket, little military style socket. It needs a bit of a deburr, so that socket's going to go on there. That works. Does need a deburr just to get rid of the burrs off there. There's a little burr there. Okay, so I'm going to solder 3 wires on here of a length enough to get up to the terminal blocks. I've got, let me see if I can show you guys here, some cable numbering tabs. They run 0 to 9, so you can make, you know, any number between 999 and 00 whatever. So, you know, all zeros or just 0. So yeah, I think hopefully I got enough in this pack to do the wiring. I want to number the wires, and I'm going to write a little legend as to what wire does what. And then it'll make it a bit less complicated when I come to put it together, as long as I write down where it comes from, and then I'll know where it goes to when I do the lathe side of it. So let's just square that up, having deburred it. I'm going to put 3.3mm holes in here at the moment, so let's just spot these holes through. And then some little M3. Probably go a lot faster than that now. Let's speed the drill up. Okay, so 4 little bolts will be going in there at a later date. Little M3 screws. I'm sure I've got some here somewhere. So yeah, that's pretty much, as you can see, that's the little outlet. And this is going to be for the main 3-phase live to the motor. So let's put that down, put that drill bit back before I lose it. There we are. So yeah, we're moving on with this. So same sort of method, just fitted these little multi-plugs. I think these are 8 pin. That'll do all the low voltage stuff and the power supply to the stepper motor as well. So yeah, so far so good. Just fitting these in. Now we need to wire the inside of the panel, do a bit of soldering. So I've just soldered the 3 wires here, 1.5 mil. That's a cross-sectional area, and I'm just going to put a bit of heat shrink on the back. So I'll do this before I fit it to the box. It's much easier to do. Lighter, lighter, lighter. Let's just shrink that heat shrink into place on all 3. Just to keep it insulated, because these will be 230 volts AC. So I'm just being double precautious on these. Okay, that's shrunk that. So I made a note in my book. There's a book I keep in the shed here with all sorts of notes and what have you. So 3-phase socket, number 1 pin on this plug. Yellow, red, blue, which are the 3 colours that are going to correspond to the motor. And that's the 3 colours that come out of the inverter are in those colours as well. I will number these using the numbers, so I'll pretty much do that next. I've just done a very similar thing. I've laid out the 4 wires, these are 8-pin sockets, 16 mil. Laid out the 4 wires from the stepper driver that are going to go to the stepper motor, and I've also, in brown and white here, put the 24 volts DC plus a neg, or 0 volts, 24 volts. So yeah, I split them up a bit. That pin's unused, and I put shrink wrap on, and I've sent them out. Does it show? Yeah, numbered them terminals by the terminal number 17, 18. This is going to be 19 and 20. I need to put some numbers on these. I'm going to do some bouncers on the top and bring the 24 volts into the top here from the top box with some bouncers, basically, so that all these 4 terminals are all 24 volt plus and 24 volt and 0 volt from the reference of 24 volt. So 1, 2, 3 here, put the numbers on. Those are from the stepper, not the stepper, from the inverter, the 3 lives. So yeah, I'm going to put the second socket in. I got another hole here. Does it show? Yes, there. I'm going to put 8 wires on there, probably do a skip, and then put 8 wires in here, which is going to be more than enough. I might not use them all, but more than enough to run all the controls from the inverter to the onboard lathe end of the, like, remote control for the inverter. I'm going to run those other 8 wires. It doesn't need that many. I think it's about 6, but yeah, we can do that later. But more of the same. And let me show those 4 wires. Let me just come around a bit. Loosen the tripod, eh? Oh, tripod stiff. What have I done here? Tighten something up probably. Anyway, so these 4 are going to be laced around. I can't remember the order when I took them out. I can go back on my video. A plus and minus, B plus and minus. I'll set those up as they are in standard, and we'll lace these down in the bottom of the box, bring them up underneath and bring them into here. So yeah, they're not going to run through the terminals. They're going to go direct from the stepper to the appropriate socket. So again, on the page of my book, I've called it socket 1, the stepper and the 24 volt DC, and I've numbered them out. So pin number 1 I've used on the socket is the red, which is terminal 4. 2 is blue, terminal 5. I've changed my mind. I was going to run them through a terminal. In fact, those are going to go direct now. I must just as well scratch them out. And I will call them what they are, A plus, B plus, that sort of thing. And that one down there was terminal 7. And I've labelled those up what they are. So pin 5 on the socket is to terminal 17, pin 6, terminal 18. So I know when I do the appropriate wiring coming out of the control boxes, what pin does what coming out of the lathe. And I'll number them. And the numbers I'm going to use are going to be appropriate to the terminal number where it's appropriate. The terminals on the terminals here, it's going to be either the terminal number, and I'll write a legend of what those numbers are from the top box, what they do and what have you, and at least I've got some sort of reference. And then at some point I'll make up a little laminated card to go inside the box here, which says what everything does. Oh, I tell you, I haven't shown this. several months ago, I did a video on a Kaiweets multimeter, and they've sent me another multimeter, which I'm not going to go and do at this stage. And they sent me a pair of wire nips, basically a Christmas box sent to me by Kaiweets. So thank you to Kaiweets. These little wire cutters, brilliant. I'm not sure if I'll use the wire strippers, but the cutters on the end are actually superb for cutting these cables. So yeah, I've enjoyed these. There were a few other bits and bobs in the goodies box. Terminals, multimeter, multi-purpose cables, that sort of thing as well. So yeah, thanks to Kaiweets for the Christmas present. They did give me a polo shirt as well, which is great for wearing in the shed here. But yeah, these are really good. No faults at all. I think I've got some Nipex ones, and I've got a couple of other sets, but you can never have too many sets of cable cutters. So I made a bit more progress. I connected up the second of the two multi-pin sockets, 8 wires, pins 1 to 8. Number 5 corresponds to pin 1, number 8 to pin 12. So yeah, I've just carried on in ever rising order, and I have made a note of that. So the big plug, I need to get some M3 nuts. I've got the bolts but no nuts to put that on. Obviously wire 1, 2, 3, that's the power for the main motor on the lathe. These 8 here, even though I won't be using all 8, are the signal wires from basically remote control for the inverter unit. The bottom plug are the 4 lives going out to the stepper motor for the drive, and there are also a 24 volt, 0 volt and 24 volt plus and minus, let's call it, going out through that lower socket. Just to explain the wiring of the stepper driver and pulse generator, I've labelled them up here. C is common, so the black line on the common goes to all the minuses, pulse minus, direction minus, enable minus on here, so it comes into the first one and then bounces onto the others. We'll talk about the red wire next, is enable, so that goes on to enable plus, and I'm going to run it through a switch, simple on off switch. As you can see, I've left 2 tails here, haven't got the switch at the moment, I only had 1 switch left. The white again is direction, so forward and back. May have to turn the switch around or swap the wires, whatever. May have to turn the switch around to change direction on the feed motor. So it comes through the switch and onto the direction plus. And then finally the yellow is pulse plus, which is directly from the pulse generator. So that's the wiring setup within that box. I've got everything numbered. I know where everything comes in relation to these wires out of which pinhole. So when I bring the wires in from up top in the upper box, I know what all the wires do in the upper box. I just put them onto a corresponding number, and I'll label them accordingly on the other side, including the 24 volt in. I need to run a ground wire in as well. I'm going to put a ground spike on here somewhere, so that I can connect a ground wire through the plastic boxes, so there'll be a bolt sticking out here with a ground wire, what have you, which will bring the ground to the motor, earth, shall we call it. So yeah, we're getting there now. I'm going to put this to one side temporarily. I need to order another switch and some M3 nuts. Yeah, I don't know, I haven't got any M3 nuts. Need to order some M3 nuts, a bag of those. It's going to be cheap as chips. And these switches are, you know, I think a bag of 4 is about a £5 on eBay or Amazon, so easy peasy to get those. I have drilled some holes in the bottom here just to let some air in, and I will drill some up in the top in this area here to let air out, just to give it a bit of through draft. There is a big heat sink on here, and a bit of heat will be generated by the stepper driver as well. But this won't be used for long periods of time, and it's under very little load, so I'm not expecting to have great problems with heat here. So back on the Webster engine. Yeah, correct belts came in. I've just fitted that on the shaft. Let me just spin that around. Okay, so camshaft's going to go down here somewhere on the block we pre-prepared. Pre-prepared, okay, yeah, well, you know what I mean. And then there's going to be some sort of tensioner on the underside at some point. So with that said, the bearings at the shaft, it's going to be a 6mm shaft, 6mm hole in here already. The bearings obviously need to go low enough in here, so this little bearing, I need a hole in here, a little bearing hole, needs to go low enough so that the OD, or the little shouldered bearing there, isn't going to break out the top. And I worked out a distance, and I've scribed it on here as low as I can go, and that is approximately there, and that's going to give me enough clearance to be able to get the belt on and off without taking well, to be able to slip the belt under, and nothing going to be rubbing on the floor. So happy with that. So next part is going to be to bolt a hole in there for that bearing to take the shaft down there somewhere. So yeah, that's the next thing. Set this block up, pick up the middle distance. You know, I forget, I'm sure I said 21mm. Let's have a quick look. I left the caliper set. 22mm. So 22mm up, middle per diddle, bang hole, drop that in there. Yeah, simple as. So the bearing OD 12mm. Just get going with a spotting drill there on centre. 6mm spotting drill. Let's just put a 6mm drill in there. Oh, head up a bit. Oh, bit of WD-40. So it's there'll be a rebate in here, 13.6 diameter by 0.75 deep. But we need to do the 12mm first. So that's the 6mm. Let's put that away. Okay, back in the box so I don't lose it. I am set up here. I've got all my drills at hand. So that's the 12mm collet in there. I want that later maybe. So that is the drill, 10mm I believe. Let's have a 10mm hole in there now. Okay, put those down. Look at that. Now I've got to bring the head back down. That should do me. Okay, that's 10mm drill. Right, let's have him out. I must get myself a chuck. That goes up to 10mm. I've got one that goes to 1/2 inch, but will go in here, but I've got to change it on the drawbar all the time. So what am I doing now? That collet next. This is an 11.5 drill. Oh, I can't quite started. Let's put it in there first. Come on. So that's 12mm collet, 11.5 drill. Let's just wind him in. Not too far in here now, we're alright. Okay. So we can go in now. Slow down a touch. Okay, and then 12mm reamer. So back out with that one. Come on, out your way. I've got a 12mm straight shank reamer here. I've had this years and years, so I know it cuts fairly tight, this one, on a 12, so I'm hoping that it works okay. Let's just lock that down. Nice and slow. In fact, I think that was like 11.3 drill, not 11.5. Oh, come on, I thought we were through there. Okay, I'm just going to try that bearing in there because I'm not convinced. I'm not convinced with that reamer, to be honest. There's a big burr on top of there. What's going on there? Sloppy as. Ah, that's really annoying. What have I done there? I have messed up. $11.934. Yeah. That reamer. Ooh, 11.98. Don't understand. Hold on. I went up here somewhere. You know what that is? That there is a 1/2 inch reamer. And it's tapered down on the end. And I've gone in way too far. If I'd have just started it, we would have been there. Two options. I know what I'm going to do. I think I know what I'm going to do here. I don't want to wreck this. I'm going to make a step shaft. I'm going to make the bearing this end 8mm bore. That's what I'm going to do. That's what I'm going to do. Okay. So, I've come out of shot, guys. Bear with me. I'm just getting one of the other bearings. The larger bearings, which are here. And we can save the day. Hopefully. Right, got plenty of meat in this side, so right, yeah, that bearing's not sloppy in there, it won't fit whatsoever. So I think what I'm going to do now is rehash this to fit this size. So I just checked, I have a 16mm reamer. I'm definitely 16mm reamer, and this one's a good one. So I need to open the hole up now even further. Not to worry, not to worry, we can do these things. I'm redesigning the shaft in my head now. I think we'll have a stepped shaft, or I can open up the hole in the gear, which was 6mm. This gear here, with a 6mm, I could change that to 8, and just run an 8mm shaft, which won't be a problem because I haven't done anything with the cam yet, the exhaust cam. So I think that's what we'll do. We're going to run an 8mm shaft. But on the far side, I'm going to turn it down to 6mm so that it fits in the smaller bearing, because I've got room or height for the smaller bearing. So yes, there we are. Just thinking on the fly, how am I going to get away with cocking that up? And that was how I'm going to get away with it. So I suppose the next thing I want to do is drill that now. There's something like a, I don't know, something like a 14mm drill. I'm going to have to go away and come back, guys, because I've got to dig out the right drills again. So 15.5mm drill. I put a 14 in. That's up to 15.5. sorting through the odd drills I got lying around, and that's what turned up, which will be fine for the 16mm reamer. I think we're going to run out of headroom here. No, I can get it out. So that's 15.5 drill. Why I had a 15.5 jobber drill, I don't know, but that's what it is. Oh no, 15.25. Okay. So sometimes you win, eh? So where's that reamer now? That should be the right collet for that. Yeah, it is. So 16mm reamer. Will I? No, not quite. No, I will. Okay. So this will give me the 16mm hole for the bearing. I'm not looking for a press fit. When I assemble it, there'll be a touch of Loctite. Just so that out. On the outside of that bearing, touch of Loctite. Stop it moving around, but I'm going to stop there. Where am I? Am I all zero? So let me make sure. Let's come out of the way. So, right, 16mm hole. So, bearing. Moment of truth. We'll live with that. Okay. Ugh. So I'm going to have to put a counter bore in here now. How am I going to do that? How are you going to do that, eh? Boring head. Does it need it? You know what, I can mess with the shaft and put it any length I want, so if that's the working face, there is no reason why I have to counter bore that in. There is no reason why I have to counter bore that in. No, there isn't. Why make work for yourself? Okay, I'm going to leave that sat proud, just using the shoulder of the shouldered bearing to stop the bearing coming out that way, and it's going to be inboard. So, right, we're there. I have collets everywhere, I have bits and pieces everywhere. Let's put all this lot away before I get confused what goes where. So, yeah, I think that got me out of a bit of a pickle there. I got myself into it, I had to get myself out of it. Let's have that reamer put away. Oh, that's one of those things that, you know, I've got a 16mm reamer. How did he put it away, dirty? I've got a 16mm reamer. Why I had it, I have no idea. From a job I had to do many moons ago, I would imagine. Hardly ever been used, so anyway, just goes to show you never know when it'll come in useful, so hang on to it. Right, I just want to deburr that hole now. I think we can use our friend Mr. Noga for that. Right, so that is that hole in it. Don't need to do anything else to it. Not at this point. Could put a couple of tapped holes in while I've got it in the vise, maybe. Not tapped holes, drill and counterboard holes, maybe. Let's have a look at that, shall we? Let's just pull that out of there. So I'm going to want two holes to hold it down onto the bed of the machine. Let's just deburr that back face while we're at it. Well, I've got it. In my hand. Obviously we'll smarten all this up at a later date. Right, that's the bearing fitted in that side. Yeah, I think I will put those holes in now at this stage. I'll work out what bolts I've got You know, it doesn't need to be super strong. Probably M4 will probably do this. I'll see what I've got. Okay, let's just centre drill 2 holes in there, 55mm apart. We are going with M4 screws. Should be able to get away with just a 4mm drill in here. Let's just lift that head a little. That'll do. Lock us head. Okay, and back to 0. So middle of the plate, middle of this axis as well. And those are going to be the 2 little M4 bolts. I've got some, obviously they're going to come up from this way. I've got some little dome-headed ones, about the right length. That's what I've got, that's what I'm using. Could, while I've got it here, just put that 4mm drill away. Little countersinking bit, 1 draw. Will that do it? I think that'll do it. I'm not countersinking, a little champering bit. Oops. That one, just deburring it with a 45-degree bit. I'll probably handball the other side. Okay, that's that done. Just pop it back out the vise. And I need, can I get in there? No, not with that bit. How long is that bit? Not long enough. Okay. Yeah, I'll find another way of doing that. Will that bit to go in there, I wonder? Maybe. Let's just come out the way. I can't quite get in there, can I? Right on the end of the shaft, let's just try. No, I can't, it won't go in there like that. I'm looking for another couple of mil, maybe just wobbling a bit for the money. I'm balling it. Alright, I've got that one. Right, that's deburred, all bar what a stone will do for me. So I've just made up a little stub shaft in that bearing housing. Let me get it out of there. Just a little stub shaft. The bearing's in its seat with the pulley on it, roughly in the right position. So I've clamped the base down onto the table of the mill, just with a square. And I've clamped the parallel again against this space with a view to getting this all square. So if I just put the belt on roughly, I've lined up the 2 pulleys. So that's going to give me, as long as I'm back, it takes a bit of holding, as long as I'm back firmly against this parallel, I can pull against the belt to put the tension in, and then I can just line up and spot through that hole. So that's what I've done. And as you can see, I've got a 3.3 hole there ready to accept an M4 tap. So my next procedure, tap that hole, bolt this down then, just make sure that it's located with the belt tight, and then I'll spot the other hole through. So yeah, that's just how I'm getting a position to get that belt tension. Not pulling it super tight, just firm enough, the sort of running position. So yeah, that's where I am with that. So just lined it all up with it bolted down on the first screw. That bolt just fits in there. I'm just touching on the stock. That's a 4mm spotting drill. Okay, so I've spotted it, so I've locked the table off. I'll take this block out of the way now, drill and tap it. Well, there we are, that's it, roughly in position, that's bolted down. Now, that belt is deflecting the shaft a little bit, so it's not a case of just spotting it across. I'm going to take the belt back off, make sure it's all seated in solid and square into here. Then I'm going to take a depth mic measurement from the end of here to the shaft. And that'll give me a centre point from the end of here. I know the height up because it's going to be the same as the height up was on here, 22 mil, and then I can bore a hole for the bearing on the other side. So yeah, remove the belt, but as you can see, that's the, I have got a couple of grub screws sticking out on this pulley, but that's the general idea. And obviously relationship between the crank and the cam is 2 to 1, so 2 turns of the crank to 1 turn of the camshaft. So I found where I wanted to be, picked it up, centred it up, and open it out for the smaller bearing, which is going to be a 12mm hole. Now what I'm going to do, I'm thinking on this now, I'm just going to check. How did you get that in there, Adrian? Okay, wind it up a touch. I'm just going to check if the larger bearing, oh, I just flexed the smaller bearing, because believe it or not, I have not got a 12mm reamer, so that would be going in there, but I'm just going to check one of the larger bearings to see if it will physically fit. Right, got one without sticking out the top. You know what, there's no reason why I couldn't go for the large bearing again, save having a stepped shaft. So that's what I'm going to do. I'm going to put one of those in there. I was planning on one of those. I know I've got the reamer to do one of those, so that is what we're going to do. So, okay, I've got some spare tiny bearings now. So yeah, same procedure as I did when I bored the other side. Drill and ream 16mm. So just giving it a quick deburr. And that fits in there quite nicely, so at least I didn't mess it up this time. So I'm not going to sink that in. I think that's absolutely fine on the surface like that. I'm going to work with it like that. I don't need the camshaft that close to the edge, so no problem at all. Yeah, I think what I need to do now is put it all back together again, with the 2 shafts anyway, not the flywheel and all. Just put it back together just to make sure that it all operates smoothly. Well, yeah, it all went together reasonably easy. This is just a dummy shaft piece of 8mm silver steel. Everything is a little bit tight. I give it a light polish so that I can slip it together easy. And, well, yeah, as you can see, little finger, I can turn it all, and yeah, it's all working a treat. So, I think that's a good point to leave it. I've been thinking again, and this could be right, this could be wrong. Normally, or in the original design, there's a set of ignition points here and a suppressor, what have you, condenser, I should call it, at this point here. So the spark cam is on here, which opens and closes the points, what have you. Because that's the crankshaft, what would happen is that you would have a spark on every stroke, so on the compression stroke and on the exhaust stroke. So because of the way I've done this, I now have a camshaft, which we didn't really have in the original model. So the exhaust cam obviously is going back here, which is going to raise the exhaust valve. But could I put the coil cam, or the cam for the points, on the camshaft, or on this shaft I'll call it, and that would then, I could time it up so that the spark was only firing, oh that's my stomach rumbling, only firing on the ignition stroke, or on the compression stroke, time it up on here. I'm wondering if that might not be a better idea. If anyone can think of any reason why that won't work, let me know in the comments. But typically, I know from my days using points and what have you, and distributors and what have you, we had to put the points in back in the day, minis, escorts, all that sort of thing, that the distributor was driven by the camshaft, which was half speed of the crank. Well, I haven't put this thing together in a while. I just thought I'd make sure nothing's fouling, hitting or whatever. No piston in there yet. Conrod's just resting in the hole there. So yeah, I mean, that's all working nicely. Got the cylinder back in. You know, it's all in place, or all starting to come into place. Yeah, I mean, there's more bits made, as you can see. So I do want to round the corners off on the top of here. I've got the ignition cam to do, the exhaust cam, rocker shaft, valve guides and valves, carburetor, piston rings, electrical system. That's pretty much it. Saying that makes it sound so simple. Piston rings, I still haven't ordered any rings yet. I think I'm going to go Viton rings in this, so I'll probably get a piece of aluminium. Well, I think I probably have got a piece here I could make the piston out of. Basically turn it to a diameter and then experiment with the rings. I'm going to get the rings to the OD that I need, and then experiment with the depth of the groove so that I get that nice fit once I've honed the bore. So I haven't put the spark plug in. Should we do that just for fun? Little spark plug. Little NGK spark plug here. Bit like a chainsaw spark plug, really. There we are, spark plug's going in there. So yeah, I mean, there's a lot to do yet, but all the big bits are done, I'd say. It's all the small little fiddly bits now. So we're getting there, we are getting there. Fuel tank, obviously we need to design something, make a fuel tank to feed the carb. Mounted on some sort of plinth so I can get the battery underneath and what have you. But yeah, we are winning, guys. We're winning now. Well, I think that's a good place to stop. Yeah, I mean, we got the camshaft in and it sort of works. Anyway, nothing rumbly grumbly, it all seems to line up and work okay, so that's good news. No fettling to be done. So I suppose moving on, we'll be looking at the cams next, maybe, and the rocker arm, and obviously finishing off the inlet manifold, the valves and valve guides. I've got plenty of material around me to do that. I'm going to make the valves out of silver steel, I think. 01 gauge, what do they call it? Drill rod, so we call it. I've got various small diameters of that, so that'll be fine for that. I've got enough bronze to make the valve guides out of bronze, so I'll be doing those out of bronze. Piston, as I said, I have got some smaller aluminium bar, but an inch round, so we can dummy that up, but I do need to order those rings, and I do need to order a set of points. I think the points I'll probably buy will be, I'll get a set of Lucas points for a mini or something like that. See how they work. You know, we may have to go for something smaller, but I'm sure we can make those work, and they're readily available. There's plenty of minis about, historic minis that are still running points and a condenser, so that's probably the route we'll go down. Only a couple of £. Might even get them in my local Halfords with a bit of luck. So that said, time of year is appropriate. We're approaching, in fact it's New Year's Eve today while I'm in the shed filming this outshot. So can I take this opportunity to wish you all a very happy New Year, and I hope you all have a fabulous 2023. And various bits, I'm looking forward to getting onto the Alexander tool and cutter grinder, or D-bit grinder, in the new year. You know, once these two projects are finished, I want to finish the Webster engine, I want to finish the mini lathe, you know, both of them all bar the shouting, and then get on with the next project. So that's that. Well, I hope you all had a great Christmas again. I didn't have anything for the workshop. I didn't put anything on a shopping list for the workshop. I think I've spent enough in the last couple of months in here. So nothing new, no new arrivals in here, so to speak. Anyway, guys, as always, thanks for watching. Thanks for subscribing. We'll see you all very soon. Happy New Year, everyone.